up 2, to the left 1. So what is that slope?
1. 2 over 1. 2 over 1.
Thank you. 2, not over,
Oh,
divided by negative 1, which is negative 2. If I look at this slope here for the orange, it's going down 1 and, don't say over, no, left 2, so it is negative 2, which is 1/2. So, are those points perpendicular?
Yes.
Or creating a perpendicular angle between those line segments, 100%. So I want to point this out, negative 1, 2, whereas this point is what? Negative 2, comma, down. Negative 1, right? I want you to look here at A. A is right here. Notice it's negative 6 and 1. But with A prime, it's negative 1, negative 6. What pattern should we be noticing here? Huh? Okay, but what, like, look at the point. What tells us that we're getting something perpendicular? But if you're looking at the point, we don't have reciprocals, right? I'm not looking at the slope right now. I'm looking at the points. The x and y are what? Switching. So y'all are talking about opposite and reciprocal, and you got to be careful because in order to have opposite and reciprocal, you have to calculate. You're talking about slope there. You need 2 points. Notice the other point is that point of rotation, right? And so when I look here, we don't actually have a slope yet, but, thank you, but to get that 90 degree, the x and the y are going to have to switch. Because how do we calculate slope? Rise divided by run or
change in y loop, change value.
So to get that reciprocal in the slope, my x and y have to switch. They have to change. To get that opposite reciprocal slope, the x and the y would have to switch. Right now, my y is a 1 divided by my x, which is negative 6. And be careful, it's not a slope right now, but it is from 0, 0, right? So it would work out something like that. And it says, while here, it's that y is now negative 6 and the x is now negative 1, which would give me 6. So in order to get opposites and reciprocals, the x and the y have to switch. Not just change, because change can be anything. They have to switch. And one of them needs to become the opposite. Now, hear me very clearly on this. You can memorize which one's going to become the opposite, but it's a pain in the butt to memorize which one's going to become the opposite. All I would do is I would think about this. I know, so I'm going to look here at just point C right now. Here's point C. That point is 1, 2, 3, 4 to the left and 1, 2, 3 up. And so if it rotates 90 degrees, what quadrant does it go into? The third, right? First, second, third quadrant. Yeah, we got to know that. First, second, third quadrant. And so we know what's going to happen with the x and the y. They're going to not just change, they're going to switch places. So I'm going to have a 3 and I'm going to have a 4. But it's in the third quadrant. X, is it positive or negative in the third quadrant? Negative. Y, positive or negative? There it is. So I know that in order to get that 90 degrees, that perpendicular line segments, the x and the y have to switch, and I just look at what quadrant it's in and determine if it's positive or negative. That's it. Now let's say that I take a 90 degree rotation clockwise, right? Currently, A is negative 6, 1. When I rotate negative 6, 1, that point A over to here to get A prime, What do I immediately know about that point? But even before that.
Go to the other side. Right, it'll be in the same.
Thank you. Say that louder.
The X and Y value will switch.
The X and Y's are going to switch, right?
Yeah.
When it's a 90-degree rotation, I know the X and the Y have to switch. I know it's going to become a 1 and a 6. But if it's going into this quadrant, what are they going? The X, is it going to be positive or negative?
Positive.
Positive. Is Y going to be positive or negative?
Mhm.
Let's check it. Is A the point 1, 6? 1 to the right, 6 up. Notice it's that simple that when we, how are the points of the pre-image and image related after 90-degree rotations? The X and Y switch. Pay attention to the quadrant. To determine if values are positive or negative. That is important to notice that when we have 90-degree rotations, right? Say again? I mean, if you don't want to know that to be able to use it later, then no, you don't have to write it down. But if I wrote it on the board, I think it's kind of important.
So the X and Y both switch, but their values are determined by which quadrant they're in.
There's a way to know exactly which one's going to be positive or negative based on the direction, but it's just so much easier to just look at what quadrant it's in to determine which one's positives and which one's negative. Because notice, like, one of them did switch, right? That negative ended up becoming a positive, and only one of them switched because I need opposites and reciprocals, but it's just way easier to look at the quadrant and say if it's positive or negative based on the quadrant. Does that make sense? Can I erase the information from 5.1? Yes? So, anybody have a guess what I would do to do a 180-degree rotation?
You double the 90 degrees.
What do you mean by that?
Like, from where, like, you just do a full 180 instead of just half of 180, which is 90 degrees.
But how am I going to do that? How am I going to know where that point's going to end up?
Determine
What do you think, Kyla?
graph.
Maybe, but what am I going to do? Am I going to just jump straight to 180?
No, you're gonna go to another point.
Yeah, if you go straight.
Can I do 90 one way and then do another 90? Yes, that's what I would do. Well, hold on a second. Split into two 90-degree rotations. That's exactly what I would do. I would split into two 90-degree rotations. There's an easier way to do it. I will point this out. Because here's the thing. Each 90-degree rotation, what's the X and Y going to do? They're going to switch, right? So if this negative 6, 1 switches to 6, 1, right? No, 1, 6. When it goes another 90, it's going to what? It's going to switch back to be 6 to the right and 1 down. So I want you to notice what happens when it's a 180-degree rotation.
They switch. X and Y switch.
Those X, and the X is 6. The y is 1 after the 180. What's different? Not the reciprocal, the negative. They're opposites. Notice it switched, and then it switched back after the second rotation, but the signs changed for both. I personally would just split it into two 90-degree rotations, but you can do one 180 by just taking the opposite of both x and y. Trent, am I boring you, my man? Get the hood off, head up. Pay attention. Sit up all the way, please. All right. So I would probably split that 180 into two 90-degree rotations. So what if I were to tell you, hey, do a 270-degree clockwise rotation? What would you do? Follow the clock. How am I going to do 270 though? I could do three 90-degree clockwise rotations, right? Or could I just do a 90-degree counterclockwise?
Yes.
That's what I would do. Because notice what's 270 plus 90? 360. Isn't that what we just talked about, that those would map to each other?
And then go into 390 to get 270.
Yes, you could do that, but remember, Nathan, I just said that instead of doing a 270-degree clockwise rotation, I'm just going to do a 90-degree counterclockwise rotation. Aren't those going to map to the same thing?
Yeah.
Right? If I go 90, 90, and then 90, that puts me here, right? Whereas if I just did one 90-degree counterclockwise, it also puts me there. I'm always, and that's why I brought up 5.1 earlier, because I want you to note, right, I'm going to make my job as easy as possible. I'm not going to make it harder than that. Comments, questions, concerns? Okay, we're about to apply a lot of this. 5.3 says, do the patterns for translations and reflections hold? When I rotate. Wait, I'm going clockwise. I need to go counterclockwise. So what do you notice about the pre-image and the image? I hear some people kind of talking, but what should we notice?
It stays the same.
What stays the same?
The
The area, the angles, the side lengths. So, this is a foundational piece to understand. With a rotation, angles, side lengths, I should say angle measures, side lengths, and area are what? Well, they're the same for the pre-image and the image, but what was the language and the objective that I used? If you have a dinosaur bone that was kept really well so that it's almost the same, it's what? It's preserved, right? The angles, measure, side lengths, and area are preserved. So we'll point this out. Since the angles, since the side length, since the area is preserved, what do you know about the pre-image and the image? They are, okay, what's the mathematical word for that? Say that louder, Bailey. They're congruent, right? Preserved is the action of keeping them the same. That's the difference, right? Preserved means that they are actively being kept the same. But if they are the same, they are congruent to each other. Okay? And so, one thing I do want to point this out, if I were to call the pre-image ABC, what would I call the image? So the triangle A prime, B prime, C prime. So notice, Thomas, to show that they are the pre-image and image, we use those primes.
I feel like ABC goes to A prime, B prime, and C prime, it isn't the same. Is that another?
Not quite, because we can also say triangle DEF would be would map to triangle D prime, E prime, F prime. Okay, and we can also use it with quadrilaterals. We can use it with pentagons, hexagons, all that stuff. Hey,
Did you make it 2 R or something?
to what?
2 R.
Where?
You said.
No, it's supposed to be just 1 R. Sorry. The side lengths. Oh, and area. That's what I was supposed to say. Are preserved. Sorry. And area are preserved.
Oh.
Yes, Emily.
Expression where it's like A and then
The primes specifically indicate the image.
okay, because like I was just wondering why they put it on with every single letter.
Well, instead of doing it,
It's like A prime to
because it's indicating specifically that A maps to A prime, B maps to B prime, and C maps to C prime. Yes, Nathan.
The difference.
Excuse me, I'm not a mathematical questions being asked that most of you can't hear because you're talking in small conversations. Quit that. Pay attention to the whole class conversation. Say again, Nathan.
What's the difference equals?
That's not an equal sign. What's that symbol that I put up there?
The different sign.
Congruent. This symbol right here means congruent. Equality is something you can do with numbers. We're not talking about numbers, we're talking about those triangles. Alright, really quickly, I do want to point this out. I need you to hear me very clearly on this. There is one other element that can be preserved with different transformations. And so I need you to pay attention to this. And it's called the orientation. Let's say I start here at point B. If I go clockwise, what's the next point? A, and then C. If I start here at this point B and I go clockwise, what's next? A prime, and then clockwise again is C prime. Alright? So hold on to that. You see how that orientation is clockwise. It goes in the same order, right? Let's look at translations really quickly. If I look here at this translation, if I start at B and I go clockwise, what do I get? Actually, I'm going to even go the other way. If I go counterclockwise from B, I get C and then A. If I go from B prime counterclockwise, I get C prime and then A prime. See how the orientation stays the same. If I go the same direction, counterclockwise, I get B, C, A for both of those, right? But let's look at a reflection. If I go from C clockwise, what do I get? That's B. Continue on, I get A. And then back to C. If I start at C prime, I get... Is that the same order of points?
No.
No. And so one last detail that I do want you to note is this: translations and rotations. Let me use a different marker, sorry. Rotations are orientation preserving but reflections are orientation, any guess what we would say? It doesn't go in the same direction, it goes in the opposite direction. Think about Uno, it goes the opposite direction. Uno reverse, right? Orientation reversing. Alright? And all that that means is if I go in the same direction, it's going to give me a different angle next with reflections, right? So orientation preserving versus orientation reversing. Yeah, so like with and it's only true with reflections. If I go counterclockwise from C, I get B and then A. But on the image, if I go counterclockwise, I get A prime, then B prime, so that's reversed, right? These are all the notes to review the transformations, but I would assume that we want to practice some with them, right? I mean, I can just, move on if we don't need practice. Move on? No practice? Oh, sweet Moses. The apathy about even making a decision of whether you need practice or not is mind-boggling. You all need practice. You don't know these things perfectly. So, this is where the rest of the packet that you have comes from. Now, I do want to point two things out. First off, what do we still need to do this week? What do you know that we still need to do?
Our test.
We got to finish our test, right? What were some of the main things that you need to be comfortable with on that test? Say again. You need to know distance formula and how to calculate distance. What else do you need? You need slopes. I will say this, to classify your polygons, what are the two major things you need? Slope.
Intercept form.
To classify a polygon. Guys, hold on. You need to be able to calculate slopes and lengths, right? Because remember, if it's a parallelogram, those opposite sides are what? Parallel. So you need the slope. If you have a rectangle or a square, those consecutive sides are perpendicular. So again, you would need the slope, right? If those opposite, yeah, because remember, perpendicular slopes are opposite and reciprocal. Not to determine, because that's only for triangles. I said if you have a rectangle or a square, you need perpendicular sidelines. If you want to check the lengths, you need distance formula. And so a lot of what we're about to do is going to help us practice that. Okay, a lot with the slopes. But I also still have tutoring. I still have the videos on YouTube that you need to go check out if you're still struggling to finish those things up. Look through the textbook, do something. I'm giving you multiple days to take advantage to study and make sure you understand this before you come in and finish the test. More than likely, based on where we are right now, you will finish up your test on Thursday. The only unfortunate part is that means that you will not have those on your progress report. And a lot of us need that because we have zeros on our understanding checks, and we need the test to replace that. You need to explain to your parents that that's where we are. Yes, Peyton?
Is there a way I can take it either tomorrow or Friday, because I'm leaving, we got a basketball game Thursday.
We're not at school Friday.
Oh, I mean.
Oh, we don't?
If you come during,
I need to take
if you can come during like your, what do you have first, second, and third? Talk to me after class quickly. Okay? So, yes, Emily. Yeah. Progress reports, listen very clearly. Progress reports are literally just progress reports, like understanding checks. Your understanding can improve, right? So I replace your understanding check grades. Progress reports are just a check on where you are at that point. It's not going to impact your final grade.
What's the difference between progress report and
That's
Your final grade, that does not change. Okay. So hopefully we can define each rigid transformation. I will point this out. Hopefully we have a good picture of what we mean by a rigid transformation. What do rigid transformations do?
They translate, rotate, reflect a polygon.
Hold on. Translations, rotations, and reflections are the rigid transformations, but what do they do? What did all three of those transformations do? Emily? Yeah, they move the figure around the graph, but not all movements are rigid transformations. Nathan?
The slopes are just like the degrees on the way that each of them are categorized, like on translate, rotate, reflect.
Not quite. They all what? They all preserve what? They all preserve the areas, they all preserve the side lengths, and they preserve the angle measures. That's what we mean by a rigid transformation. It's rigid because everything stays the same. So if you have a rigid transformation, the pre-image and the image are going to be, what's the mathematical word for that? Congruent, right? The rigid transformations, the translations, rotation, reflections, they preserve the area, the angle measures, the distances, so that the pre-image and the image are congruent. Okay? So am I going to give an assignment on the Khan Academy on this information? I haven't decided yet. I might assign it tomorrow, but not today. Alright, so we can translate, rotate, and reflect polygons. Sorry, I didn't realize that I wasn't talking so that y'all could talk. No? Oh, I am talking, right. Thank you, pay attention. I can identify preserved elements under each transformation, and I can, this is the new one, I can identify what transformation has been applied to get an image when given a pictorial representation. But here's where we're starting. I'm just going to get you started on this question. Number one, we should be looking at the packet. It says reflect triangle DEF across or about the what? Y-axis. Then fill in the blanks with appropriate responses. So like, if I were to look here at point F, that's the point 3, negative, I think 6. No, negative 5. If I reflect this over the y-axis, what does point F become? Yes, but what are the coordinates for it? Notice it goes from 3 from the y-axis here. It's a reflection. Remember, it needs to reflect perpendicular to the line of reflection, and it needs to go the same distance to the other side. Negative 3, negative 5 is where that would now be. And I would call this point what again? Which prime? That's F prime. There we go. Where would D be? Right now it's negative 1, negative 2. So after the reflection it would be? So I will point this out. You can memorize what you're multiplying the negative by, but you can also just look at the graph and go 1 to the other side. Notice D prime is 1, negative 2. Because we have the opposite of the x. Remember, if it's over the y-axis, which direction is that? There's an H word. Horizontal. And which variable is associated with the horizontal? X. So we're multiplying the x by negative 1. So there's my D prime. And then E prime. Is going to be right here. I believe that's negative 6, 4. And so now I can draw my triangle. Look at it. Does that look pretty congruent? It's a rigid transformation. So, we now want to start looking at these answers. I'm only going to look at one with you. You should be able to get this information on your own pretty easily. If the measure of angle F is 70 degrees, so this angle F right here is 70 degrees, then the measure of angle what? What angle would we know pretty quickly? Yeah, we know about F and F prime, right? What would the measure of angle F prime be? How do you know it's 70 degrees?
Because if the prime is the same as the other.
I need more detail than just that. Nope. Not a protractor. Say again. Because it's a reflection, which is a... Huh? Come on, there's a term that we just talked about. What type of transformation is it?
Rigid.
It's a rigid transformation, right? And all of the rigid transformations preserve angle measures, side lengths, and area. By the way, does anyone remember the other word for rigid transformation? Isometry, right? All right. Work with those in your small group to answer these questions. I will point out again, if it's talking about the slope of DE, which slope do you think we're going to talk about here? D prime, E prime. Right? So we're connecting the pre-image to the image. All right, answer as many of those questions as you can. Moving through, Joey, it helps to have the right page.
I don't know what page we're on.
Dog, use your eyeballs, man. It's the number one.
So we're talking.
We even have the point right there. But you see how that doesn't even get room into this. Hey Jada, what are you doing, man? You're not even trying to do some math. Hey, by the way, hey, listen up really closely. We're about to pack. Don't pack yet. I will come unglued if you pack early. Yeah, unglued.
What's that mean? What would that mean?
I will become irate. I will be angry because y'all are packing early. Listen. Pause and listen. What should you be able to walk in and grab tomorrow to help make sure that your pre-image and image have similar line segments? A straight edge. Use a ruler to draw your lines and line segments. Is that clear? All right. One person per group. Calculators up. You may start packing. We've got no, we're not going over to the cell phone caddy. Sit back down. No bell rings.
Are you serious?
Yeah, I'm dead serious. Yes.
Are you serious? You don't make a secret of my not. Well, you're
By the time you go in,
Excuse me. Sit down.
stop. You don't.
By the way, I need y'all to check through your stuff, your backpacks. When I was out, my son was born, one of my calculators went missing. I need it back.
How you know?
I'm telling all my classes.
Oh, okay.
So, I assume that someone accidentally, I hope someone just accidentally walked out with it. I need that calculator back because I need calculators for all my classes. I got 30 students in 2 different classes next semester, so I need all 30 calculators. I do too. Oh, bring that back.
What?
She told you one time to make it work. You didn't niggas remember saying my ears?
Oh God, you count.
Remember.
I'm talking counting.
I didn't want to hear that. It was the first thing that day. Remember, because Kendra had outside.
Oh God, it was. Because you gotta tell me you ain't. You not saying nothing to me.
Look, remember we was in our books,
Okay,
right?
but you have the notes, right? So that when we work through this package,
You was sitting there, you playing with your head.
Don't
She
answer the
said,
question.
are you going to do something?
Okay. Stop making it complicated. We just started looking.
That was.
What's up?
No.
But she literally told you.
I can, but I haven't graded that. What's up? Go for it.
One, have you finished reading?
No. Just barely started yesterday. Go for it though. What's the next question?
2 was the x2 positive negative